Hello there. I'm so excited to have you here again. This is a question that was requested from someone, and it's on longitude and latitude. It's a very interesting question, and I will try to explain in details as much as possible. I will not totally assume that you know some of these. Okay, good. So let's dive into the question. The aeroplane flies due west for 3 hours from P, latitude 50 degrees north, longitude 60 degrees west, to a point Q at an average speed at 600 km per hour. The aeroplane then flies due south from Q to a point Y, 50 km away. Calculate correct to three significant figures: A, the longitude of Q, B, the latitude of Y. Take the radius of the Earth equals 6,400 kilometers, pi equals 22/7. So when you see questions like this in longitude, you should first of all know that you need to draw the globe. Okay, and when you see these points given, for instance, we are given latitude 50 degrees north and 60 degrees west. That is a specific point mentioned on the diagram. So you should rejoice when you see that. And I hope you know that on this diagram we have the north and the south. Okay, then we also have the western and the eastern region or zone. Alright, there are imaginary lines. For instance, we have the equator, which goes this way. For sake of time, I won't do that, but we have an imaginary line here. We have another imaginary line. So the equator separates the northern hemisphere from the southern hemisphere. Then the Greenwich Meridian line separates the western zone from the eastern zone. Alright, so let's dive to the question straight ahead. So let's indicate latitude 50 degrees north and 60 degrees, longitude 60 degrees west. So as I said, from the equator, the latitude varies from 90 degrees north to 90 degrees south. So start from the equator here, start counting up to 90 degrees. So we're told that the first movement is on 50 degrees north. Alright, then the longitude is at 60 degrees west. So it's going to be on the zone. So we're going to draw that just right away. Okay, so this is 60 degrees west. So this is point P. Then we are also told much earlier that the plane flies due west for 3 hours, that is from P to get to Q. So it flew on the same latitude 50 degrees. Okay, so this is the longitude. Okay, so this is Q. Alright, then we're also told that the plane then flies due south from Q to a point Y. Sorry, this is 500 kilometers away. So it flew from here down, that means it's coming down. This is southern hemisphere, coming towards southern hemisphere. So we're going to have another second line of movement. So this is Y. Alright, so the given hours, average speed, and the distance traveled are going to matter immediately after we draw this. So let's dive to the first question, which says that we should calculate the longitude of Q. Then you may begin to wonder what is going to happen. Remember, let me just draw a cross section of what happened right here. So we're told that there was a movement. This is where P is at. This is P. So it traveled 60 degrees west. Then it continued, okay, to Q. All right. So for this longitudinal difference, we don't know. So let this be X. Okay, then we're told the distance, the average speed it took from year to year. So normally we're going to use the length of an arc to find the distance, the formula for length of an arc to find the distance between P and Q. So the distance between P and Q is equal to the given difference X, or the unknown difference, sorry, over 360. Remember the formula, 2 pi r, this is the capital R, the radius of the earth, then cos theta. All right, so remember the distance, we don't have the distance, but we have the average speed. And if you can recall the formula for finding the average speed, let us quickly do that by the corner here. Remember that speed is equal to distance over time. So distance will be equal to speed times time. And the speed given, we're told that the speed given in the question above is 600, and the time it took to travel is 3 hours. So we have distance equal to 1,800 kilometers. Good. So now we're looking at 1,800 equals X over 360 times 2 times the pi given is 22 over 7, then times the given radius of the earth, 6,400, then times cos theta. The cos theta is the parallel of the latitude, which is 50 degrees. Okay, good. So now if we do our calculation, that is, we have X equals 1,800 times 360 times 7 to be divided by 2 times 22 times 6,400 times cos 50 degrees. Okay, so if you punch that in your calculator, you are finally going to arrive at X equals 25 degrees approximately. Okay, and the longitudinal difference, okay, so now we have this as 25. Okay, so the longitude of Q is going to be what? The longitude of Q is going to be, it's traveled from this 60 plus 25. Did you get that? So, and that is going to give us 85 degrees west. So that is the longitude of Q. All right. So let us find the latitude of Y. All right. So now we are looking at the distance between Q and Y along the parallel of longitude, this longitude of 85 degrees west. Okay, and so we're still going to apply the formula. So this time around, you know, we were told that it traveled 500 kilometers. So we have the distance 500 kilometers this time around. Then the difference in the longitude, we don't have that. Let that be Y. Okay, to be divided by 360, then times 2 pi. The pi, we have that 22/7, then times the radius, which is 6,400. Okay, so now if we cross multiply, we have y equals 500 times 360 times 7 to be divided by 2 times 22 times 6,400. All right, so for you punch this in your calculator. Okay, for the sake of time, I'm not doing that, but you ought to do that. So you're going to arrive at 4.48 degrees. Okay, so that is the difference. Okay, but if you see, according to the diagram, according to the question, it dropped. Okay, had it been it went north, we would have added that 4.48 to 50 degrees north to get the latitude, but it dropped. So what that means is we're going to subtract that from the first movement. So the latitude of y is equal to 50 degrees minus 4.48. Okay, and that is going to give us 45.5 to 3 significant figures degrees. Okay, not. All right, so this is to 3 significant figures. So this is the final answer. Not to worry, I'm going to bring up another question. And solve that. That may throw more light on this. Good. I hope this helped. Thank you for watching. See you some other time, or see you in the next video. Bye bye.